Hello, welcome back to my channel, the Seyfert Lectures channel. Here is where we discuss the processes of nature, what happens inside our bodies, and what happens outside of our bodies in the natural world. These are processes that, whether we like it or not, whether we know it or not, they are happening. And it's better for us to know and understand them so that we can understand their signs and deficiencies, and so we can know how we can rectify them. This is why these lectures are being made, for us to understand what is happening both inside of us and outside of us. We're still dealing with the human body, and the last lecture we discussed about the B vitamin complexes, that is the water-soluble vitamins. We divided the vitamins into water-soluble and fat-solubles. The water-solubles, we listed them as 12 of them, out of which we said 4 of them were taken out because our bodies can make them. So now we were left with 8 plus vitamin C, which is 9 of them. We discussed about 4 of them in the last lecture, which were thiamine, riboflavin, niacin, and pentatonic acid. We have discussed their deficiencies, what can happen, and their food, so the sources where we can get them from the food that we eat. So today we're going to continue part 2, which is going to discuss about the rest of the B complexes. Four of them left, plus vitamin C, making 5. We're starting with pyridoxine, we'll move to biotin, we'll move to foliate, and then cobalamin, ending it with vitamin C. Now here is pyridoxine that we're going to start with. It's a group of vitamins. It's a group of them, namely pyridoxine, pyridoxal, and pyridoxamine. All of these are vitamins and are metabolized into pyridoxal phosphate. Pyridoxal phosphate acts as a coenzyme. Here we need to remember what a coenzyme is. It's not an energy-making molecule. Coenzymes are helpers. They help the enzymes to catalyze reactions that will help make the energy that we need to survive. So without coenzymes, enzymes cannot do their job properly because they need help from these coenzymes. And these coenzymes are all embedded in the food that we eat. So for B6, pyridoxine is fortified in this food that you can see on the right hand side. So we need to be consuming this food to get the pyridoxine because our bodies cannot make it. We have to put it inside our bodies. The reactions they help making is they help to make blood. They help also in the central nervous system. They help also in the nucleic acid biosynthesis. And nucleic acids are very important. They are the basis. They are the base molecules of DNA. DNA has 4 base molecules, which are adenine and thymine, cytosine, and guanine. These are nucleotides that are in DNA. So it helps in the synthesis of these nucleotides. So it's very, very important. We need to understand that. Okay, then if you don't have them, this is the problem. Because of we have just said that it helps in the making of blood. Blood that carries oxygen is called hemoglobin. It's the red blood cells. All the cells in our body needs oxygen. We have over 36 trillion cells in our bodies. And all of these cells need oxygen to do their job, to perform their function so that we can continue to be alive. Without the oxygen, then we cannot be alive. And it is this hemoglobin molecules, the red blood cells, that carries this oxygen all over our body. That is why wherever you cut yourself, you see blood, because blood has to go everywhere in your body. And its job, one of its job, not all the job that it does, one of its main jobs is to carry oxygen. So if you lack vitamin B6 and you're deficient of it, it can lead to what is called microcytic anemia. So your blood cells can be very, very small, smaller than blood cells themselves, because blood cells are the smallest cells in our body. They are so small that they don't even have a cell nucleus to keep DNA in there. There is no DNA in red blood cells because they don't have any space to carry DNA. All their job is to carry the oxygen, so they don't have time for DNA. What they have time for is to absorb as much oxygen as possible and to pass it around your body for the survival of your cells. So if the cells of red blood is so microcytic, is so small that it cannot carry sufficient oxygen, then you are in trouble. It leads to fatigue, it leads to lethargy, it leads to tiredness, sleepiness, and exhaustion. So these are not good, and these are the signs and symptoms that you can see in your face. So vitamin B6 deficiency is not good. We need to consume them. Now we move to B7. These are the food sources where you can get vitamin B7, and it is very good also, and it is required in the embryonic growth. That is, a pregnant woman is necessary for them to consume vitamin B7 biotin. It helps in the growth of the fetus. So the fetal growth, it helps there. It also helps in blood sugar regulation. It also helps to promote nervous system health. So it is very important. If you don't have it, it might have delayed growth in the child that you are bearing. It might have low birth weight. So the child will be born but will lose a lot of weight, and some birth defects also can be seen. So biotin is important for pregnancy. The deficiency of it, you can see, the first sign will be hair loss. That's the first physical symptoms. You have hair loss, and I do advise sometimes people who may drink cocktails, which includes raw egg whites. There are some cocktails, alcoholic cocktails with raw egg whites, because biotin, it binds to avidin, which is a protein in white, in egg white. The protein in egg white is called avidin, and biotin binds to it. So if it binds to it, then your body cannot absorb biotin, because the biotin cannot get into your body because the raw egg white is already binding to it. So consumption of raw egg white, a lot of it, will lead to biotin deficiency. Okay, I know that people don't just go and start drinking raw egg whites, but we have to be aware that it's one of the reasons why you can have biotin deficiency. Um, it can also be a genetic condition, which is called biotinidase deficiency and holocarboxylase synthase deficiency. These two are recessive diseases that you acquire from your parents. Your parents can be a carrier of these defective genes, and then as a child you're born by these parents, then you can inherit either a biotinidase deficiency from them, or you can inherit holocarboxylase synthase deficiency. That one, what it does, is a genetic defect that is affecting biotin dependent enzymes. The enzymes that are dependent on biotin to work, that you will not have it. Or you're born with that deficiency. So this is not very good. Okay. So then you have B9, which is folate, also very important for pregnancy. I know most women who are pregnant or who has gone through pregnancy might witness me here that maybe their doctors might have advised them to be taking folic acid, because that's one of the first things that your doctor should advise you to take, folic acid, because it's very, very important in the development of the child that you are bearing. So folate is crucial for the synthesis of nucleotides as well. There again, nucleotides, which is the DNA, the building blocks of DNA and RNA, making it essential for cell division and tissue growth. Red blood cell formation. Folate is necessary for the production of maturation of red blood cells. Deficiency can lead to megaloblastic anemia. Megaloblastic anemia is different from microcytic anemia. Megaloblastic anemia is that your red blood cells become so large, so big, so immature that also they cannot carry oxygen around. So that also is not very good for your body. It is also crucial for neural tube development in the fetus. This is a neural tube. When the child is developing inside the mother's womb, there is a tube that the cells start. It started with a single cell, and that divides into two, into four, into eight, into 16, into 64. As it grows to be a big ball, it starts to curl up on itself to form the neural tube. That's the tube which connects the central nervous system back to the brain. So, if that tube is not closed properly, then you might end up having what is called spina bifida, or you can end up having anencephaly. Anencephaly also is here. You can see the completion of the head is not completed, so the brain is not completed. You get half of a head. This is not compatible with life, so you might have a miscarriage. Your child will die. If it is also a spina bifida, which is shown here at the back of this little baby, the spinal cord did not close properly, and this is the example, with the cross section of it. If you cut the child in half, this is how it looks like here. The spinal cord did not close properly, and also that is not compatible with life, so you might have a miscarriage. So folate is very, very important for pregnancy. If you are pregnant, you have to check with your doctor to make sure that you have enough folic acid, or you might have to be taking folic acid supplements. Thank you for listening on that one. And please be aware that this is what it does. And these are the food sources that you can get folate from, folic acid from. It's fortified in all this food. Okay, then we come to cobalamin, which is B12. Vitamin B12 is called cobalamin. The problem with cobalamin is that vegetarians here in the West, there are people with different type of dietary function, dietary needs. Some of them are vegetarians; they don't eat any meat. Some of them are vegans. They don't eat any meat or animal products. Even milk or egg or something they don't eat because it's an animal product. But vitamin B12, which is cobalamin, is only existing in animal products, animal food products. You don't have it in vegetables. So if you are a vegetarian, or if you are a vegan, you don't eat animal products, you only eat vegetables, then you definitely need to have some supplements for vitamin B12. It helps in red blood cell formation and prevention of anemia, DNA synthesis, and the repair of neurological functions. It also maintains health of the myelin sheath, which insulates nerve fibers. Now, the myelin sheath needs to be understood. Okay, let's take an analogy of a house. That the body is like a house. When you're building a house, you need structures to support the house, like pillars and all the rest of it. So that in our bodies is the bones. Our bones are the structures on which we stand on. And then we are covered with the flesh. But inside the flesh, like a house is covered with blocks and mortar and everything, but inside that you have to run your pipes for your water and your drainage. You have to run your electrical wirings for your lighting and everything. So the body is also the same like that. We have pipes in our body, which is the veins where the blood is passing through. We also have electrical wiring, which is the nerve fibers, which are sending signals across to the brain and to any part of the body. Whatever touches you and you feel it, it has passed through a nerve and get to the brain for you to feel it and to make a reaction. So with electrical wires that are outside in our house, they have a covering. There is an insulator that covers the electrical wiring. The wires are inside the insulator, so that it will not get ripped, it will not get damaged, and it will shock anybody. Likewise, in the human body as well, the myelin sheath is the covering that covers the fibers, the nerve fibers, where the electrical conductivity is passing through. So these nerve fibers needs to be covered so that they are protected, and the myelin sheath is what does that. So cobalamin helps to maintain that myelin sheath so that it will not be destroyed or degraded, so that it will expose the nerve fibers so that they can get damaged and disrupt the communication between your brain and the rest of your body. It's also good for mental health. It is important for producing neurotransmitters and can influence mood and memory. Neurotransmitters as well, they deal with the fibers because all the neurological transmitters passes through the fibers so that they can communicate with other neurons and other parts of the body. So cobalamin is important. And deficiency of it also, as I said, will cause megaloblastic anemia. That is big red blood cells that cannot carry oxygen, and it can cause also neurological symptoms such as numbness, tingling, and cognitive impairment. Low levels of it has been associated with depression and confusion. It can also cause jaundice, what is called jaundice. Jaundice is not only caused by lack of cobalamin, but cobalamin is one of the causes of jaundice. Jaundice is the yellowing of the skin and the eyes. And it also can cause these nasty things in your tongue and your mouth. These are called ulcers. They are ulcers in your mouth and in your tongue. So if you see these things, just be diagnosed for low cobalamin before you can do anything else, because it could be one of the causes that can cause it. Right, and these are the food sources where you can. No, sorry, this is now vitamin C. The food sources where you can get vitamin C, and you can see that vitamin C here. There is no animal product here shown in as vitamin C. Most of the products here are vegetables and fruits where we can get the vitamin C from. And its use is to neutralize harmful free radicals in the body. It protects cells and tissues from oxidative stress. Now, free radicals are what happens is that we take in oxygen to live, but oxygen attacks our bodies, our cells, because oxygen has an electron that is free. Electrons need to go in pairs. Oxygen have one electron that is not paired, so it is only one. So that electron will try to seek a pair from somewhere else, anywhere. It can get it from your DNA or any other tissue. It will pinch one electron so that it can get pair, so that it can be all right. And when it pinches an electron, it leaves that electron unpaired. So that electron will also move to get paired by another electron. So it will release a cascade of events in your body where electrons are trying to find pair from everywhere, and this damage the tissues in your body. Now, antioxidants, this is what they do. They have a spare electron in them. So before your body starts to cascade and damage your cell, it will tell you, hold on, I have a spare electron here. Have this one. So your body will pair with that one, and then it will not damage anything. So that is why antioxidants are very important. It's also good in collagen synthesis. Collagens are the sticky tapes of the human cell, body cell, or the animals. All animals have collagens in their bodies. It's what puts their cells together. When we come to discuss the evolution of single cell to multiple cells in the history of life, in the history of the planet, then we will have to explain where collagens came into action to help transform the single cell to multiple cell. Immune system support, it enhances the function of the white blood cells also, so that you can have proper immune system support. Wound healing, for your wounds to be healed speedily, vitamin C helps in that. It helps also to prevent scurvy. Scurvy is this is scurvy. It is like the red blood cells will rupture. The red blood, your veins will start rupturing, busting up, and leaking of blood in everywhere in your body, and look in your gums as well. So this is part of scurvy, and this is a lack of vitamin C deficiency. It's a lack of vitamin C. So it is a deficiency. It creates swollen blood bleeding gums, slow wound healing, and frequent infections. This is what vitamin C is all about. Now, guys, that was the end of vitamin B complexes, the water solubles, and these are the references that you can go into to see and to read more about what we have just been discussing. I thank you very much for listening, and please, if you like this video, click the thumbs up button. Make some comments if you want, ask some questions if you want. Please share it, and please um, uh, rewind this and play it again and again to understand what it's all about. So thank you very much for listening.